If you're running video streaming, financial market data, or real-time gaming across multiple VPCs and you're still using Unicast to send the same data to hundreds of receivers, you're burning bandwidth and money. I just helped a fintech company cut their data distribution costs by 60% by switching to Transit Gateway Multicast.
Hey everyone, welcome back to the Network Ninja Cloudcast. I'm here with our resident cloud architect, and that sounds like a pretty bold claim.
Great to have you here. Today we're diving into one of AWS's most underutilized features for one-to-many communication. Trust me, by the end of this episode, you'll understand exactly when and how to use it.
Okay, so let me set the scene. I'm working on a project where we need to send the same stock price updates to trading applications running in 15 different VPCs. Right now, we're sending 15 separate copies of every message. It feels wasteful.
That's the exact pain point Multicast solves. Think about it this way. With Unicast, if you have one sender and 15 receivers, you're transmitting 15 identical copies of every packet. Your source is doing 15 times the work, and you're paying for 15 times the bandwidth.
So multicast is like a radio broadcast instead of making 15 phone calls?
Exactly right, and that analogy holds up technically. With Multicast, your source sends one packet to a multicast group address, and the network infrastructure replicates it only where needed. The sender doesn't even need to know how many receivers exist.
Wait, I thought multicast didn't work in the cloud because it relies on special network protocols that cloud providers don't support.
That was true until 2019 when AWS launched Transit Gateway Multicast. Here's the key thing to understand. Traditional IP multicast uses IGMP, that's Internet Group Management Protocol, for receivers to join groups, and PIM, Protocol Independent Multicast, for routers to build distribution trees. AWS Transit Gateway handles all of this for you within their managed infrastructure.
So how does it actually work? Walk me through the architecture.
Let's break it down into three components. First, you need a transit gateway with multicast support enabled. This is a checkbox when you create it. But here's the catch, you cannot enable multicast on an existing transit gateway. You have to create a new one with multicast support from the start.
Good to know. What's the second component?
Multicast domains. A multicast domain is a logical grouping that defines which VPC attachments can participate in multicast traffic. You create a domain, associate your transit gateway attachments with it, and then register your sources and receivers. Each domain supports multicast group addresses in the 224.0.0.0 out of 4 range, which is the standard Class D multicast range defined in RFC 1112.
And the third component?
The actual group memberships. You register ANIs, elastic network interfaces, as either sources or group members. Sources are the instances that send multicast traffic, and group members are the receivers. Here's where it gets interesting. You can either statically register members through the AWS console or API, or you can enable IGMP support and let your applications dynamically join groups.
Let me make sure I understand. If I have my stock price publisher in VPC A and trading apps in VPCs B through P, I'd attach all those VPCs to the transit gateway, create a multicast domain, register my publishers any as a source for, say, group address 239.1.1.1, and register all my trading app any's as members of that same group?
Perfect understanding. And once that's configured, your publisher sends UDP packets to 239.1.1.1, and Transit Gateway handles replicating them to all 15 VPCs. Your publisher still sends just one packet.
Does this work across availability zones and regions?
Across aws within a region, absolutely. But here's a limitation people miss. Transit Gateway Multicast does not support inter-region multicast. If you need to distribute to VPCs in multiple regions, you'll need a multicast source in each region or a different architecture altogether.
What about the biggest mistakes you see people make?
Number 1 is forgetting that multicast only works with UDP. If your application uses TCP, you cannot use multicast because TCP requires a connection between specific endpoints. Number 2 is not checking the any limits. Each multicast domain supports a maximum of 1,000 group members per group. If you exceed that, you need multiple groups or domains.
So to recap, Transit Gateway Multicast lets me send one packet that reaches many receivers across VPCs. I need a multicast-enabled transit gateway from the start. I create domains and register sources and members, and it only works with UDP within a single region.
Nailed it. My pro tip is to start with static group membership while you're learning. Then move to IGMP-based dynamic membership once you're comfortable. Go spin up a test transit gateway and try it yourself.
This is going to save us so much bandwidth on that market data project.
That's it for today's episode. If you found this helpful, Please hit that like button and subscribe to the channel.
And share this with anyone who's dealing with one-to-many data distribution in AWS.
Thanks for watching the Network Ninja Cloudcast. See you in the next one.